For the Chapter 11 problem, you need to do stepwise regression in order to find the solution. So we need to perform regression until we get to a model that has only significant variables. So in order to do that, we're going to run regression just like we did in the Chapter 10 problem on these variables, and then we're going to analyze the data to determine which variables to drop, and then we drop them one at a time. And as we drop them, eventually all of the variables remaining will be statistically significant. They'll have p-values lower than 0.05, which is going to be our threshold. And then we can check the other stats on the model, like the R-squared, to see that it's still a good model, and then we'll use that to make our predictions. So I'm going to show you two steps, but I'm not going to complete this. I'm going to have you continue the stepwise regression until you find the solution. So our dependent variable is pork sales. That's what we're trying to depict. And then our input is all of the variables to start. And I actually forgot. One of the other things we were asked to do was to see if the time period was also a regressor. So I need to fill this series all the way down and include that variable as well. Okay, now I can run my regression. So I go to data analysis, regression. Again, pork sales is going to be my dependent variable, and my independent variables to start will be all of them. Includes labels, so I need to check that box. I'm going to put it in a new worksheet. I'm going to label this worksheet by right-clicking and rename and call it regression 1 so I can keep track of my regressions. And then the best way for me to figure out what you've done is for you to highlight the first variable that you're going to drop. So if we look at the coefficients for all of these variables, the intercept we don't care about. In our equation y equals mx plus b, b is the intercept. It doesn't matter what its p-value is. We're just going to go with it. But for the coefficients for the variables, these are what we care about, because if they're not statistically significant, that means that 0 is included in their confidence interval, and so therefore that variable we can exclude from the model. So looking at this, there's actually quite a few variables that are above 0.05, but the highest is the time period. So this is the first that I'm not going to use. So I'm going to run my regression again, and I don't need to rearrange any columns because I'm dropping the last column, but if I were to drop income, I would need to cut this column by right-clicking, cut, and then paste it over here so that all of my variables are next to each other. That's the one caveat to running regression in Excel. So I'll do one more step, and then I'll have you guys finish. So right now I have columns C, D, E, F, and G. I'm getting rid of the time period, so I'm just going to select C through F, run it again, right-click and rename my spreadsheet regression 2, and look at my p-values again. So in this scenario, now it looks like my highest p-value is population. So I'm going to drop population. So in order to do that, I would cut this column, and I'm just going to paste it over here so that the remaining 3 variables to try are included, and I'm going to run regression again. So you're going to keep doing this until all of your p-values are less than 0.05. And you'll find that as you drop variables, it's possible that a variable that right now has too high of a p-value will become significant when you drop a different variable because of multicollinearity or other issues. So don't assume that because right now they're not significant doesn't mean that they won't be included in your final model. You have to do one at a time. And then when you finish your equation, so let's say you get down to 2 variables. So remember the equation y, so ry in this case is pork sales, that's what we're trying to predict, equals our intercept, or b in the equation mx plus b, plus, and then this is our coefficient 1 times our variable 1 plus coefficient 2 times variable 2. So when you finish your model, if it had 2 variables left, you would calculate your prediction by plugging in the intercept. So let's say this was the final model. This intercept here plus the variable coefficient. So if pork price was one of the one of the variables that remained in the final model, it would be negative 0.34 times the price. And when you get your that's this number here, and then you also add in your second variable, whatever it is, and so when you go to the final problem, you would take the information they gave you about price for your prediction, and you would simply just plug it into this equation, and then whatever your second variable was, you would take the information that they gave you and plug it into this equation and use the intercept times the value they've given you, and that will give you your prediction for that next time period. Okay, so that's all. Hopefully this will help you finish out the problem, and as always, reach out to me if you have questions.